In this video, I introduce a histogram of oriented gradients. Histogram of oriented gradients is used to represent a 2D image as a feature vector by using the gradient at each pixel in the image. Suppose that fxy indicates the intensity at pixel xy is a gradient vector is defined here. Namely, we can use 4 neighbors to calculate the gradient at pixel xy along x direction and y direction. Magnitude and direction of the gradient are defined here. For example, we can use 4 neighbors to calculate gradient at pixel xy. This is magnitude and this is the direction. To detect a face in an image, we group 8 by 8 pixels as a cell. And then now we calculate the gradient direction and the magnitude at each pixel. We create 9 bins between 0 to 180 degrees. And then now we correspond this gradient direction to each bin here. For example, direction 80 corresponds to bin 80. We add its magnitude into bin 80. If the direction is 10 on the edge between bin 0 and bin 20, we add half of its magnitude to bin 0, half to bin 20. If direction 0 on the edge between bin 0 and bin 160, we add half of its magnitude into bin 0, half to bin 160. And then now we calculate the contribution from all the pixels in one cell, and we generate this 9-bin histogram. And then now we are group 2 by 2 cells as one block. And then we generate this 36-bin histogram for each block here. So total, we have 36 bins for each block. The L2 normalization is applied on each block. A 2 by 2 block moves one cell each time along the x direction or y direction, which generate 7 by 15 blocks for this image. The final length of the HOG vector is 7 by 15 by 36, namely total we have 3,780 bins for this image. A classifier, for example, support vector machine uses the HOG vector as an input to classify if image contains a human. For more details, please check with these references. Thank you.